Okay, now, so in item 11, you have to find the missing values. We are given with a situation here that there is a 2 kilogram box at rest on a table. So I have to find the acceleration, the net force, and the value of the individual forces acting on the object. So we have to draw a free body diagram first, right? So since the object is only at rest, or since the object is at rest on a table, the table will be exerting a force, an upward force on the object, which is manifested here as the normal force. And since the object has a mass of 2 kilogram, it would have a weight or a gravitational force acting downwards. So these are my only forces acting on the object. You can easily find the gravitational force since that's only mass times acceleration due to gravity. Your mass is 2 kilogram and you multiply that by acceleration due to gravity on Earth, so 9.8 meter per second squared. Your weight or your F sub g or your gravitational force is 49 newtons. So the object is at rest. That means it's not accelerating or the acceleration is 0. Therefore, there are no the forces cancels out or balances out. There is no unbalanced force. The net force is 0. If you sum the forces along the y, so Fn and Fg should be equal to one another. So Fn is positive, subtract that by Fg. The sum of the forces should be equal to 0. The net force is 0. So that means the net force is equivalent to the gravitational force, which is 49 newtons. For item 12, similar situation or similar approach. We have a 2 kilogram box, but at this time it's not at rest. It's sliding to the right across a table, and it is experiencing a frictional force equivalent to 5 newton. And I have to find out its acceleration, its net force, and the value of the individual forces, again, acting on the object. So since it is sliding on top of a surface, the table, it should be experiencing a normal force from the table. So it has a mass, that means it has a weight as well. It's mentioned in the problem that it is experiencing a frictional force since it is sliding across the table. So again, we can compute for the weight, the gravitational force easily. Again, it's equivalent to 49 newtons. It's sliding to the right. That means the net force is present along that axis and not on the vertical axis. So that means Fn and Fg cancels out. They have the same value. So if you sum the forces along the y, it should be equal to 0. So the net force is equivalent to your gravitational force for the forces to cancel out. So your normal force is also equivalent to 49 newtons. So it is the weight of that object, of that 2 kilogram box, pushing on that table. The weight is equivalent to 4.9 newton. As a reaction to that weight, as a reaction to that push down, the object will react by exerting an upward force of the same magnitude but opposite direction, but in the opposite direction. Okay, that's the law of action-reaction, third law of motion. So as a continuation, we have to find out the net force. The net force is present along the x-axis. Since friction force is the only force on that axis, that's already the net force, or it is the frictional force causing the unbalanced force, okay? Or causing the acceleration of the object. Acceleration can be computed using the formula net force divided by the mass. So we have a negative net force, negative 5 Newton divided by 2 kilogram. The acceleration is, that should be negative 2.5 meter per second squared, or 2.5 meter per second squared directed to the west. On the item number 13, we have an elevator. So that means we're expecting tension here. A 5 kilogram freight elevator is moving upwards towards its destination. Near the end of the ascent, the upward moving elevator encounters a downward acceleration. So we're given with acceleration 2 meters per second squared, and we have to find out the net force and the value of individual forces acting on the object. Again, since we have an elevator, we're expecting for tension to be present in the free body diagram. Since there is an acceleration, I should be able to compute for a net force. My net force should not be equal to 0. So this is my free body diagram. We have a tension lifting the elevator up, and of course it has a mass, so it has a weight as well, or it is experiencing the gravitational pull of the Earth, as all objects with mass are experiencing, including us. So the net force can be computed easily, no? Since we have the value of the mass and the acceleration, which is downwards. So let's put a negative on that 2 meters per second squared. My net force is, of course, also negative. The direction of the net force should be the same as the direction of the acceleration. So 500 times 2 will be 1,000 newtons. That's my net force. So since I have my net force, I can compute for the value of the individual forces. So for the weight, just the product again of my mass times the acceleration due to gravity, 500 times 9.8 will be 4,900 newtons. So you would expect that the weight will be greater than the tension for the object to accelerate downwards, no? Since that will lead to an unbalanced force directed to the south or downwards. So if I sum my forces along the y, my tension is positive and my weight or my gravitational force is negative. So I already computed for my net force. So I will put that on the left side of the equation, since the left side is the summation of forces, or my net force or my unbalanced force, which is negative 100 newtons, equal to tension, I don't know my tension, minus gravitational force, which is equivalent to 4,900 newtons. So if I put this on the other side, it will become positive. Negative 1,000 plus 4,900 newton will be 3,900 newton. That's my value for tension. Again, my weight is greater than my tension. That's why there is an unbalanced force directed downwards, and the elevator is accelerating downwards because of that particular unbalanced force. Okay, on item number 14, we have already a free body diagram. And net force, or normal force rather, gravitational force and frictional force are not given or are unknown. Net force also unknown. And acceleration, also you have to solve for the acceleration. But we are given with the mass, 5 kilogram mass, and the coefficient of friction, which is 0.1. So looking at this diagram, free body diagram, you can easily solve for the gravitational force, right? Since it's only the mass times the acceleration due to gravity. So my gravitational force will be 4.9 newtons. From the free body diagram, it looks like my net force is present along the y. And again, just as most cases, my gravitational force will be equal to my normal force. The forces along the y-axis cancels out. Okay? So my normal force will be also equal to 49 newton. This is the equation. This is the computation showing that. I have to solve for the normal force to compute for the frictional force, since frictional force is the product of the coefficient and the normal force. So my coefficient of friction is 0.1 and the normal force is 49 Newton. So the product will be 4.9 Newton. That's my frictional force. Since that is the only force present along the x-axis, that is the one causing the acceleration. No, or that is already the net force. Negative 4.9 Newton since it's directed to the left. Okay, so we can already solve for the acceleration here. Acceleration will be equal to the net force divided by the mass. The net force is negative 4.9 Newton divided by the 5 kilogram mass. So 4.9 divided by 5 will be 4.98. Newton divided by kilogram, again, is meter per second squared. So my acceleration is also negative, or to the west. Same with the direction of the net force. Okay, item 15 is the same type of problem. So you will approach it in the same way. So we have 4 forces present on the object: normal force, gravitational force, applied force, and the frictional force. So right here, you're given with the mass of 5 kilogram and acceleration of 2 meter per second squared. So already you can solve for the net force. Also, you are given with the coefficient of friction, and it is equal to 0.1 as well. No unit for the coefficient. But let's first solve for the gravitational force. Again, it's 49 Newton since we're given with the same mass. And we will assume that the forces along the y cancels out again. So along the y-axis, when we sum the forces along the y, it should lead to 0. That means the normal force exerted on the object by the surface is equivalent to its weight, which is 49 Newton. So again, you were able to compute for the normal force. That means you can solve for the frictional force by multiplying that by 0.1. Your frictional force is 4.9 Newton. There's no way for us to solve for the applied force without first solving for the net force. So solving for the net force, mass times acceleration, 5 times 2 is 10 newtons. Why is that? Because we can already sum the forces now along the x. So the frictional force is negative, and you will add the applied force positive. My net force, I just computed for my net force, which is 10 newtons, equal to my frictional force, which is negative 4.9 Newton. Now, I can solve for the applied force. So putting the 4.9 on the left side of the equation will transform the sign to a positive 1. So 10 plus 4.9 is 14.9 Newton. That's the value of my applied force. So there you go. You were able to solve for all of the forces or all of the unknowns.